Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
Good. So sorry we're a little late getting started. I was thinking in my head we start at 11. And thanks to Lucy, she's like, shouldn't we start? And I'm like, oh my gosh, you're right. So I'm Rane Johnson, and I have the best job here in Microsoft. I get to spend half of my time working on education research and how do we really transform the future of teaching and learning and technology. And then the other half of my day job is to really look at how do we grow more women computer scientists. And as all of you in this room know, we don't have enough of them. And when we think about products and services that are being utilized, over half the population is females, and if we don't have females making them, are we really hitting them in the right spot? And so what I'm excited about today is that we have some of our wonderful faculty fellows here to talk to you about what inspired them to become computer scientists, what happened in their university to help them be successful, and what things would they suggest to other universities to do so you could have more great women researchers who are really changing the world and thinking forwardly. And so our agenda today is Lucy and I are going to kind of give you an overview of the situation, and then each one of them are going to talk about the great research they're doing, their investigations, their experiences, and then we'll go into a panel discussion and really give some words of advice, hear from them, and then open it up to the audience and let you ask any questions that you have of the panel. And then we'll close it out with some call to actions, some things that we think that can help you and your universities to attract more women and more women faculty, and how we can work better together moving forward. The last thing that I want to talk to before we really move into Lucy's overview and the statistics and the great information that she puts together in the work she does with the Academic Alliance around the country is just a little bit of the statistics. You know, we've all heard them. You should have them memorized by now. But you know, the thing for us to really think about is between now and 2018, there will be 1.4 million open jobs in the United States in technology. And at this current rate, boys and girls, we will only fill 29% of those jobs. So the only option that we are giving tech companies is to go out and hire internationally. So how do we really make a difference? And when I go into classrooms and I talk to young women across the world, one of the things they always bring up is the lack of role models, the lack of going into a university and seeing other women faculty in computer science that they can look up to and understand and see that this is a great place for them to be. And so that's why I'm really excited to hand this over to Lucy. And I'm going to kind of fast forward. I was going to show a video on the faculty fellows, but I think Peter and Tony did a great job explaining what the Faculty Fellows is, and you saw them on stage and you heard their stories, and so I'd much rather just jump to Lucy and let her tell you some of the information that will get us started today. Which way does this go? This way. Okay, hi everybody, Lucy Sanders, I'm the CEO. Technology. Oh, my mic. Hold on. Okay. And I just want to paint a landscape for you here around women's participation on computing faculties, because that's really what we want to be talking about here today. We, of course, have information across the entire pipeline. We're over 300 organizations, K-12, not-for-profits, universities, corporations, startup companies, all working really hard to increase girls' and women's participation in computing. So today, in terms of the faculty, here are the statistics in terms of hiring faculty all the way through associate professor and full professor. And you can see, and this is from the Talby survey, you can see that we're making progress in terms of women's participation as computing faculty, and this would be at the research institutions. Still not enough. We'd like to see, of course, along the line, these representing more like 30%, because that's the tipping point that we know from a research perspective, that when you start to see at least 30% of an underrepresented group in a population, that it ceases to be a conversation.
Okay, so we're trying to get to 30% and moving up to, in terms of full professor. That would be the goal. I'm going to go through this really fast so we can make up a little bit of time. More data, also from Talby. We know if we look into the pipeline in terms of PhDs granted, 19.8% of the Talby schools report that therefore, their PhDs are going to women. If you look more broadly at the IPEDS data set, which would be a broader range of schools, you would see roughly 24%. And we know also from work by Joanne Cahoon and CRA that, in fact, over half of the women who are in a PhD program think about quitting sometime in that program, probably right up to their second year or so. That's higher than the percentage of men that think about quitting. And what would you think the main reason might be? Why do you think they think about quitting? Children. Sexism. Okay. Well, it's actually confidence. Okay, they don't have the confidence in their own abilities, and actually their confidence is not less. I mean, their abilities are the same. It's just that their confidence in their abilities is less. However, if they are subject to sexism, in the program, they're 10 times more likely to leave. And this isn't just blatant sexual harassment. It can be very subtle. Okay, so if they feel like they don't belong for some reason, they're going to be 10 times more likely to leave. So if you look then at tenure, we start to also see some encouraging statistics around paper authorship. This is from a study on ACM conference technical papers, where you see women's participation in authorship increasing. And this is, of course, due to the increased numbers, but they're also writing more papers. They're becoming more productive in there as well. It's not just a matter of sheer numbers. And we also start seeing some universities putting programs in place through NSF advanced programs for institutional reform or other efforts where they're starting to really work hard to make sure that when women are hired onto the faculty that they advance through tenure and onto full professorship. So one popular idea is the stopping the tenure track, making sure that there is time in there for starting families. And then restarting it. And of course, the best programs allow it for both men and women, not just women. That way you make sure that everybody has an option to take it if, in fact, it's needed. And then we also see reports around women on faculty, junior, even untenured women being asked to take up more of the service load when it comes to things related to gender. Okay, so another idea, which we could talk about later, is more men, and thank you to all the men in the room here, more men need to be also taking up that service load, so that, in fact, the people who are in the majority are helping right the balance. So the people who can maybe least afford to take on the service load are taking on the service load. So I just wanted to point out Georgia Tech. You can read more about this. We can get you more information as one program, but there are others that are really doing great work on campus to advance women computing faculty members. Georgia Tech has a long time been active here. They have an online interactive career tool. They have an active mentoring program for faculty women. They have workshops that are sponsored by their NSF Advanced Grant. And they really have this very numerical, they're driven by metrics. They want to see women advance to full. So obviously, we talked a little bit about departments taking action. I wanted to stop for a minute. You can read some of these, but I wanted to just give you my bottom line editorial statement on this. I'm a computer scientist, so I'm not a social scientist. So please bear with me as I give you the engineering rendition of social science, okay, which could get a little scary. You'd probably turn off this streaming camera at this point in time. So the way I understand this, and the research is pretty conclusive, society itself is very biased when it comes to women and science. You can take these associate bias tests where you can go online and you take this little test where you yourself can figure out if you think more men are great scientists or more women, and do you really attribute science in women? All right, so 72% of our population is biased to not look at women as great scientists. I happen to be in the top bias class myself. Right, so proving yet again that both men and women in society have these biases. And unless we think that bias is bad, actually bias is a great human thing to have because it helps you sort all the information you come across every day, all those big data problems. You know, your biases and stereotypes help you sort. I'm not talking about in a negative way. All right, so you don't have to relearn what a car is or what a shopping mall is or what a cow is. Right? You've been training yourself all this time to understand these things, like what's the right behavior for a cow. Right? So biases and stereotypes in and of themselves are human, right? But they can get in the way and cause severe mischief when it comes to judging people and their abilities. Right? So we bring all that into our work. We bring that into our academic departments. We bring that into our classrooms. And then when we do have underrepresented groups, things go badly for them. Right? Because the stereotype is that they're not good at it. Right? So that kind of unintended bias, and it triggers something called stereotype threat then in underrepresented groups, causes for a very strange cultural dynamic in our departments, in our faculty meetings, in our classrooms, that all we really have to do, and I'm not minimizing it, is A, recognize it, and then B, kind of get in the way of it and say, wait a minute, there's something wrong here. So I guess bottom line number one is learn the research. Learn about unintended bias. Learn about stereotype threat. Just learn about it. It's pretty interesting. And then you can get into this kind of research, like recommendation letters. This is where it actually shows up and could hurt your career. They've looked at recommendation letters. They've looked at performance write-ups. They've done associations around write-ups for women, write-ups for men, and the language around how we describe technical accomplishments. Now, these are for medical students, but it could be similar for tech. So we know that when women are being talked about, they are attributed mostly with softer attributes. And when men are being talked about, they are attributed the technical, the research. And I remember going back when I worked at Bell Labs and I started thinking about the performance write-ups I wrote. And I often said, oh, she's a great collaborator. Great, could also be a great researcher, all right, great developer, wonderful scientist, So again, I'm internalizing this myself, that these kinds of things are real, and we really have to get a look at them. These are some resources, and I'm sure these slides are available to you somewhere that you can, CRAW has got some great programs for faculty women, ACM and ACMW also. In terms of like regional meetups and newsletters and things like that we can start to put out there. And really for both men and women, these are important. And then NSF has some wonderful grant programs around advance and others for institutional reform that your university can apply for. We have resources at the new NC website where you can go and search for resources. We have mentoring in a box for faculty women. We have practice sheets around unintended bias and stereotype threat. We have the top 10 ways you can keep women in your programs. And we have a new top 10 card for men, the top 10 things that men can do to support technical women. And this is new primary research because we got a little tired of just always studying women. Okay, like why do women stay? Why do women go? But we wanted to understand those wonderful men who support technical women as sponsors and why they do it and what they do so that we can encourage more men to do the same thing. So those are the kinds of resources we have. And I guess I'm done. So bottom line, there's a lot you can do. And I'm going to put in one personal appeal. If any one of you wants to write a bias checker or do research on bias checking and write a software program to run write-ups through or to run performance appraisals through, looking for bias using the research that we know from the social science side to actually create an online tool, I'd like to talk to you. Thank you.
Everyone hear me? Excellent. All right, let's try going for it. All right, good. So I'm Emma Brentskill, and I'm an assistant professor of computer science at Carnegie Mellon University. And Rane asked us to all give a brief summary of the research we do. So I focus on artificial intelligence research, and I'm particularly interested in applications to educational technology. So I think there are three key opportunities available right now in education. The first is that education itself is a provider of opportunity. And I think that's one of the key reasons why education is strongly associated with poverty alleviation. Now, the second opportunity for education is for us simply to provide education. There are over 69 million primary school-age children that currently don't get to attend primary school. This is one of the reasons why universal primary education is one of the key goals of the Millennium Development Goals. So I think that there's a really strong demand to do this, and technology can help. Technology can help us scale up content delivery, and in fact, we're seeing amazing advances on that. MIT over 10 years ago now started putting their online lectures available to the public, and there's been a huge recent interest in massive open online courses. But I think the third opportunity is to provide not just education, but quality education. I think we have to move beyond standard classroom instruction and actually, let's try that currently, and actually provide education that we think will lead to robust student learning. There's a lot of evidence that the current way we do education is failing our citizens in terms of providing them with key mathematical and other skills. But there's fortunately a lot of evidence of how we can do better. So there's work from the 1970s that suggests that one-to-one, human-to-individual tutoring can yield to performance gains of 2 standard deviations better than standard classroom instruction. I think we can use technology to try to replicate this in a way that isn't possible in terms of providing every student with a single teacher. And there's encouraging evidence that using intelligent tutoring systems can yield significant performance gains. So I think that's the final opportunity, and I think there's much more to be done. So how do we get there? I view teaching as an instance of a sequential decision-making agent making a number of decisions about how to help a student learn in order to maximize some objective, like high school graduation rates or learning a new language. Part of my lab's work focuses on mathematical models and algorithms for automated instructional policies. Our work includes how to make decisions in single episode processes, because if we teach an 8-year-old fractions and in doing so discover a better way to teach him fractions, we can't reset him to be an 8-year-old that doesn't understand fractions and try again. The second thing our work involves is new risk-sensitive algorithms that move beyond expected outcomes to try to maximize objectives like ensuring with high probability a student will pass a statewide exam at the end of a year. And finally, I think there's a huge opportunity in education to address one of the key challenges in artificial intelligence, which is lifelong learning agents. These are needed in order to create things like self-optimizing software systems that actively suggest pedagogical activities in order to gather information about what teaching is effective and improve its future teaching. I think that these sort of systems, will help us critically scale quality education. The other thing they wanted us just to mention is what we feel about becoming a Microsoft Faculty Fellow. To me, I'm really honored to be a Microsoft Faculty Fellow, and I think it'll greatly help me build a group passionate about this type of interdisciplinary research. Thanks.
All right, hi everyone. My name is Magda Balazinska. I'm an assistant professor at the University of Washington and actually happily soon to be associate professor this fall. So yeah. What I'm working on, I actually do research in database systems. I like to build systems that process different types of data. In the past, I did a lot of work on processing data streams. Think about sensor data, data coming from ticker feeds, etc. And we worked on it just, how do we process it, and then what do we do if the data is actually inaccurate, imprecise, and so on. And more recently, I started to work on just, moving from streams in precisely to just processing big data in general. So let me tell you a little bit more about that side of my more recent research. So as we all know, science is really facing this really interesting and challenging data deluge. Scientists create these instruments such as, increasingly large-scale telescopes that produce large amounts of data. They're going to survey the sky, build collections of images. They want to process these images. They are also producing increasingly large-scale fine-grained simulations that simulate, oceans. They simulate the universe and so on, and they produce also lots and lots of data. In biology and medicine, we have new lab automation techniques such as gene sequencing that produce increasingly more data. if we can analyze all this data, we can really accelerate discovery in all the different sciences, but it's not easy to actually process all that data. So scientists need some tools to process this kind of data, and this of course goes beyond science. So internet companies, Twitter, Facebook, Microsoft, Google, all have lots of data. They want to process that data. So why is this actually interesting and challenging? So let me give you one example. So we started to work with some astronomers, and what they wanted to do was just simulate the universe from the Big Bang all the way until today, and they simulated every few simulation time steps. They take a snapshot of how the universe looks like, and the first thing they want to do is just cluster the data to see that, what kind of structures are emerging. And we said, okay, well, let's try to take this analysis and transform it from, the manually written C code to actually using some sort of data processing system such as Microsoft Dryad, which is actually what we used, or Hadoop. And we said, okay, how hard can it be? We're going to, actually, let me go back. I guess the animation, it was just, okay, what we can do is simply start with the data that we have, partition this universe into as many machines as we have, find clusters locally, and then combine these clusters. And when we did this, we run it. We run it on a small data set, a few tens of gigabytes on just a couple of nodes. Took us an hour to cluster one snapshot. Then the simulation keeps going. We get another snapshot. It took 20 hours. And we said, okay, there's something wrong here. Why is this so hard? And actually, when we looked at the debug run, what we discovered is that a lot of the data was being processed extremely quickly, except from some corner of the universe that was extremely dense, and the algorithm was taking forever, and we had what is called data skew. So this is one example where if we take what people have today, they have all this data, they want to process it. If we just translate this need into queries in parallel data processing systems, yes, we can get it to work, but the performance is not always what we want. And we can do several things. Of course, we can change the algorithm to avoid having this bad property, but that takes a lot of tweaking and tuning. So the kind of research that we are doing is to say, I don't want the user to have to do anything. Let me do it automatically for the user. So what we build, let me just say this briefly here, is something called SkewReduce, which is a tool that runs on top of Hadoop that takes a sample of the data as input, asks the user to reason about their complexity of their algorithm, and automatically partitions the data such that we automatically get this fast 1 hour runtime independent of the simulation snapshot, independent of the data set. And we actually tried this technique on many different algorithms and data sets, and we saw improvements by a factor of 6 to 8. So 6 to 8 times faster than just running with Hadoop out of the box. We took this further. We built another tool that dynamically looks at what's going on in a Hadoop workload and automatically adjusts and repartitions data, reassigns it. And we saw also improvements by a factor of 4. We saw similarly what happens. People often want to do iterative processing, recursive processing. Well, if we are smart about it, if we tell the system about it, again, we can get runtime improvements easily of a factor of 2. So this is just an example of the kind of work that we do. People have lots of data. They want to process it. Can we build systems so that they can just think about the kind of question they have to ask, and we automatically deliver high performance out of the box without them having to do any tweaking and tuning? And we are looking at this on the system side. We're also looking at this from the perspective of the interaction a little bit between the machine and the user. And here we're thinking about things such as, if I'm going to author a SQL query, everyone can write a select from where query. This is not very complicated. But often users don't quite know the schema. It's a community data set. And we can tell them. We can say, for example, well, given the query that you're writing right now, I can see that a lot of people who wrote similar types of query also use the following user-defined functions or the following complex domain-specific predicates, and we can recommend these automatically. If someone runs a query in a Hadoop cluster and they get just this bizarre performance, why did this go so much slower even though I used more machines? We actually have a system that uses machine learning techniques to help and actually explain these performance oddities. So this is just kind of a very quick overview, and there's kind of links if you want more information about the kind of research that I do. What I wanted to mention also very briefly is that I actually did all of this while also doing a couple of other things. One thing is I actually have 2 daughters that are age 1.5 and 4.5, and the picture at the bottom shows that I actually do know who they are. Which is nice. My husband and I actually also built a house from scratch, which was kind of a nice and interesting thing to do. Very exciting. How do I do this? To do both kind of great research, get awards and everything, and also have actually family. I'm actually not a superwoman. I just get a lot of help. So this is all my different relatives with me at different conferences with my babies. So then I could actually nurse. So all my babies were nursed. Every single time they needed to eat, I was there for them, which is exciting. How did I manage to do this? Because people are very understanding. I actually gave distinguished lectures when my kids were 2 months old, and I just told people, I actually don't need that much. I need an office. Your chair has 2 offices, I discovered. Chairs have 2 offices, their professor's office, their chair's office. They can't be in 2 places at once, so I just borrow one for the day. I stuck the nanny there, whoever the nanny happens to be, and then they take a walk every 2 hours. I just come and have a half an hour meeting with my baby. So this, you can get it to work. And people are very accommodating and understanding. The question is just to figure out what works for your family, what works in your case, and just ask people, and people are really happy to try to make things happen. So this is it. And what does it mean for me to be a faculty fellow? I think the most important to me is just the recognition. Right? It's really important. As an assistant professor, if I can list more awards on my resume, this is always great, makes a great impression, and having that recognition just is a huge difference. So this is really great thanks to Microsoft. This has been a huge help for me. Also, just having ties with industry is great, especially for systems research. And finally, I mean, the money is also very, very nice. So this is, why is it nice? Because there are no strings attached. So this is, if I have a crazy idea, I want to try something, I know I already have my, Microsoft faculty fellow pot of money. What is actually nice is that I got it in 2007, we're in 2012, and I still have quite a bit of money from that pot, so which is really nice because I can still think of my risky ideas. So that's it. Thank you.
All right, I guess I'll try to juggle this with both hands. So hi, my name is Mariah, and I'm an assistant professor in the School of Computing at the University of Utah, and also a faculty member in the Scientific Computing and Imaging Institute. So this is the University of Utah, and there we are at the School of Computing. The university is sort of nestled in the foothills of the absolutely beautiful Wasatch Mountain Range. It's a fantastic place to do things in the outdoors, or so I'm told by my husband, and from what I can see from my office window. As I mentioned, I'm also part of a large research institute at the university called Scientific Computing and Imaging. Our acronym is SCI, and in most parts of the world you would pronounce that SCI, but because it's Utah, we pronounce it SCI. So it's the SCI Institute, and we're about 200 people, grad students, staff, researchers, and 14 faculty from computer science, bioengineering, and also from electrical engineering. And we sort of focus on 4 main areas. We have visualization, scientific computing, image processing, and biomedical engineering. So a little bit just about sort of my own background, which was a bit untraditional. My undergrad degree was actually in astronomy, and so I sort of early on sort of developed this passion for science, but at some point realized that I wasn't actually a scientist. I like to build things. So I ended up going to the University of Utah for a PhD in computer science, followed by a recent postdoc at Harvard, which was probably the best job of my life. It was amazing. It was an opportunity to go off and explore some new research fields and figure out really what I wanted my sort of research career trajectory to be about. I also had a chance to work for a year as a visiting scientist at the Broad Institute, which is a large genomics center in Cambridge. So as I said, I sort of used this postdoc as an opportunity to explore my own sort of research passions and ended up switching research directions. So while my dissertation work was much more about geometry and image processing and medical imaging, I ended up moving in my postdoc to designing interactive visualization tools that support complex data analysis, and specifically working very closely with biologists. These tools are really about capturing effective visual representations of data and really trying to match the mental models of the scientists I work with and how they think about their data, and also combining those with intuitive interaction mechanisms to help them explore and understand what's going on in their data sets. So one of the things I found that's been so important and influential in sort of the research process I've adopted is to really start working on these collaborations when the scientists are at their earliest analysis stages. And so at this point, I usually, come up against the statement of, well, I just kind of want to see what's in my data. I have no idea really what I'm going to find in there. And so there's this awesome opportunity as a computer scientist and as a visualization researcher to go in, work with these scientists at this early stage, and to not only support them, but to also influence the kind of questions they're asking and the kind of sense-making they're doing. And there's been multiple examples in the projects I've worked on where this sort of early intervention has actually caused them to come up with new ideas that lead to new experiments and paths that they never really thought of initially. So it is truly a sort of multidisciplinary team effort at solving these complex biological problems. And then I'm also very interested in sort of using sets of these kinds of projects to think a little bit more about, can we articulate a clear process and methodologies for conducting this kind of problem-driven visualization research. And so then there's just some images over there on the left from some of the systems that I've developed. And I think that was it.
Okay, so I think it's working now. So my name is Wei Wang, and you can see my affiliation right now is UCLA. Actually, I just joined UCLA about 2 weeks ago. So, so large part of my career was actually done at UNC Chapel Hill. I spent 10 years there, and including the time when I received the Microsoft Faculty Fellowship. So I'm going to share with all of you a little bit of my past 10 years at UNC. And so I'm coming from the background of doing data mining. And when I was a graduate student, actually my area was doing data mining. And I have been doing that since then. So, and lately, I just do a Google simple search, and I guess right now we should say search on Bing, right? So, and then you can see that in the top journals and scientific articles that people talk about the data, right? And right now the most interesting topic would be the big data, right? And that's definitely not necessarily limited to data mining, but all these research challenges related to analyzing, storing, searching, and organizing all the huge amount of data. So I'm coming from the background of just analyzing the data. So as you can see, data is everywhere, and all of you have know that there's many of the, it's just subset of things that the companies, agencies that collect a lot of data or happen to have a lot of data, right? And some of them use it every day, like buy things from Amazon, we watch movie from Netflix, and so on and so forth. And sometimes some place collect data that we may not necessarily use every day, like the national security agents, right? But they do it anyway. So basically, if you search like how many papers published in data mining, analyzing data, right? All kinds of data. In the past 20 years, that's about how long that field of data mining is, starting from the term of data mining being proposed. It's over 2 million research papers. And there's tremendous of progress has been made over that 20 years and in those 2 million papers, but still, we are facing the bottleneck here, right? So you have a huge amount of data, and then you want to fish out what are the useful ones, what are the patterns hidden in the data, and then somehow fit into the subsequent analysis, correctly. So that's a big challenge, and I don't think we have all the solution we need yet. We have more challenge actually than we have the solution. So being at UNC, actually for the past 10 years, I benefit from the environment where there's a huge medical school and there's public health, and there's a lot of activities there that are actually related to biology and medicine. So I actually shifted the focus of my research towards analyzing biological data. So so basically, that's, you can see that you somehow have this biotechnology. Actually, there was a lot of advance in the past 20, 30 years in the ability of acquire data at all resolution, all the way from, the traditional actually patient level all the way to the molecular level. So it's amazing how much data they can collect. Right now, if you think, well, there's a patient, you can genotype it, or you can sequence the sample, and then probably you heard of the company like 23andMe, and then so you can send in your samples, and then a few weeks back you can get all your genotype back and look at what kind of good and bad genes you may have, and compare your genes with your actually family members. I did that because I have a twin sister, so it's interesting to see what's going on between us. So you can see that actually view data manias actually figure out what are the puzzles in the data, right? Piece them together. So. And one big project I have done in collaboration with many scientists in genetics, biology, pharmacy, and at UNC is really use mouse and as the model organism study for disease. And most of the diseases are actually we call it complex trait. Basically, they're not controlled by a single gene or single genetic variation we see on the genome. Actually, it's a result of a combination of quite a number of genes, most of the time unknown, and also the environmental factors. So it becomes a very complicated system that's required. We actually acquire data like the genotype. Sometimes maybe if you study, you heard of like gene expression data, and then sometimes if people look at the protein level and the protein-protein interaction, sometimes you collect the mass spectrometry data, and there's lots of data. And then we are building systems that actually try to inform what are the interactions between different genes, how they together control or influence the trait that are of interest. And the reason we use the mouse model is because we have better control of their environment. For human, we can ask all kinds of questions, but there's little control we can have, right? How they grow up, what they did or they didn't do in their childhood actually influence the risk of some risk factors. And we use mouse, and actually we can use that to control from the day they were born, right? What kind of housing we give them, what kind of food we give them, whether we put them together with other siblings or siblings of the opposite sex or not. So there's a lot of things we can play with, so that would help us to dissect the data and then try to fish out patterns. Of course, we're not limited to that, and then we actually want to borrow what we learn from the mouse world to the human. Actually, one of the big projects, this is an international collaboration with a group of scientists from Netherlands. Actually, we want to study disorder, mental disorder, and using the twin register at the Netherlands, and then we again collect all kinds of data we can collect from the sample. There's like about 5,000 people, and then we use the model we learned from the mouse, and then to apply that and expand it using the additional information we get from human, to try to figure out what's going on there. And it's a quite interesting, actually. A journey for me as a computer scientist to participate, because my job is to do data mining, data analysis, whatever the pattern I can find out, they're interested in looking at, and then they want to do follow-up tests to verify that. So all of this, actually, I'd like to thank Microsoft to give me the opportunity, because actually I was one of the first batch of the faculty fellows. At that time, actually, Bill Gates was one to present the award. So, in addition to that, I also get another award. It's one of the eScience Award in a few years back, and also supported one of my earlier research project on protein structure study. So, with all of this, I think my personal experience is that this award really opened many doors for myself, and because as someone interested in doing interdisciplinary research I would say like around 10 years ago when I just joined UNC, my sense then was that you have to do actually at least twice as harder as other people who just are doing research within computer science to demonstrate, to basically establish yourself, to make people in both worlds to really believe in you that actually you know what you're doing, you can do great research. And with this Microsoft faculty fellowship, actually that part becomes very easy. I can see the transition, after I got this award, and which actually, amazing ride, like for the next 10 years, because I got early tenure, early promotion to full professor, and then recently I moved to UCLA. So, and I don't think that would happen without this award. Thank you.
So we're going to transition now to a panel discussion because we have these amazing women, and I want to have the opportunity for all of you to be able to ask them the questions and the insights that you need to have so that you can grow more faculty in your own institution. So I'll kick off the panel with a couple of questions, and then our folks in the red will have microphones, and please feel free to raise your hand and they'll bring you the mic and ask the questions to anyone on the panel. So with the first question that I have is, not many women get their PhD in computer science. And so what is it that got you excited to want to do a PhD in computer science and then kept you going so that you didn't drop out, and that got you excited to really want to follow a career in research and to be a faculty member? Go for it.
I guess for me, I started off doing physics in undergraduate, and then I realized I might need a job. So I did computer science at the same time, and I ended up really loving it. And I still thought I was going to do physics in graduate school, but I had a operating systems professor called Brian Brashad at University of Washington, who said, "You're actually pretty good at this, and maybe you should think about doing computer science." And I thought, yeah, whatever. And then he said, "No, really, you should apply to grad school." And so I applied to one graduate school because they didn't require the computer science GRE. And I got in and I visited, and I was kind of suspicious about MIT. It doesn't always have the best reputation for being a fun-loving environment. But I went and I just met tons of people that were really excited about what they did, and they didn't all wear capes. So I decided to go, and I loved it. It was just fantastic. And I think one thing about computer science is it's so forward-looking, and there's still so much low-hanging fruit. Like, there's just so many interesting, cool things to be done. And so it was just a great opportunity, and I loved MIT. It was a really great environment.
I guess I had a similar experience in the sense that I didn't know I wanted to do computer science. I went into computer science because precisely I had no idea what to do. So my parents told me, if you don't know what to do, then just try computer science. So I was like, I tried it, and actually I liked it. Why I went for a PhD? Because I wanted the adventure. I was in Canada and I wanted to move to the States. So I thought, oh, let me apply for a PhD. And I did get in. I also got into MIT, and I went to MIT. And then I discovered that that was actually the first place in the world where I really felt like it was so fun and I really belonged. And it was great, and it was really a lot of fun, and just, the research is interesting, the work is interesting, so I just never looked back. I think this is a great career.
For me, it was sort of a combination of two things. In between undergrad and grad school, I worked for a few years for a very, very large company in the defense industry sector, and it was not as sort of stimulating and exciting as I knew things could be. So that sort of reality of what the real world was like, coupled with taking some computer science classes and finding myself early on in a computer graphics class, and sort of being exposed to things like computer graphics and visualization, and it's sort of striking me that in visualization, but also in computer science at large, this is, we're in this awesome field where you have the opportunity to sort of work in many, many other sort of disciplines and domains. Like anything that you kind of have a passion about, there's probably some sort of computing thing that you can do in that field, and that kind of, I tend to have a short attention span, so that sort of variability was very, very appealing to me. So that was really what drew me to getting a PhD. And also, to answer your question about what sort of kept me in, I'd have to say it was along the way being really fortunate to have some amazingly supportive mentors that sort of kept encouraging me to stay in, which reminds me that I didn't tell my sort of story I wanted to say about what the fellowship means for me. And basically, I have to say confidence, exactly sort of what you were saying, Lucy. When I came back, for the fellowship, finalists are invited here to give a 5-minute talk as an interview process. And I came back from that trip back to Utah and went out to dinner with a couple of faculty members. And they were asking me how it went. And I was like, well, I really got to at least present my research to an amazing panel of people. that's about the best I can hope for. And that night I got home, and one of the faculty members, who is a senior woman at the University of Utah, sent me an email saying, I'd like to take you out to lunch to talk about your confidence level. And she was basically like, you need to have more faith in yourself, people believe in you here. And then when I got that sort of email saying congratulations, I was besides myself. And it really, deep down for me, sort of helped validate that the direction I'm pursuing and the research I'm doing is truly sort of important, and people see it as sort of an innovative way forward. And that's so far been the thing I've gotten the most out of this.
I guess for me it was easy because my family and my parents are all in the science and engineering field. So I just I was exposed to the areas like math, WE, and when I was very young, and then I didn't want to be the outlier of the family, so. And my sister also in computer science. She's doing research in networking and at AT&T, and then we had this long debate whether data mining is better or networking is better. I think with the recent initiative of the big data, I may win this debate. I hope.
Thank you. Lucy, I would love to hear your perspective.
Well, I just wanted to say, maybe you heard a theme in here around encouragement. I mean, encouragement is one of the things that we can do, and it's free. And encouragement isn't fake praise, right? It really is valid encouragement. It's validating excellent work. And so often it goes unsaid, right? I mean, we all know that. It goes unsaid. And when you're dealing with a group that's underrepresented, encouragement is really important. Really, really important to get the confidence. Certainly not all members of underrepresented groups lack confidence. Okay, we don't want to put that stereotype out there, right? But I really feel as if this encouragement, either from family, okay, or from professors, from friends, hugely important. It's really backed up by the research in all cases.
Thank you, Lucy. So my second question, I think back when I was an engineer and undergraduate, and I wish I had one of you on our staff. And so there were no women faculty in our CS department, and there was only one woman faculty in the mechanical engineering department. And she became a mentor to me and really helped me. And unfortunately, I didn't become a computer scientist. I became a mechanical engineer. And so can you talk about what is it that you do to inspire the next generation and to grow more women like yourselves in your university and in your institutions and in your programs?
I think that I generally think that there should be a lot more representation of all underrepresented groups, and I actually think that the biggest place for that is in K through 12. When you look at the numbers, it's about 14%, I think, of women in bachelors, and then about 19 or 20% in PhDs, and then about 24% in faculty. So actually, the pipeline isn't bad. In fact, it's slightly expanding when you look at from bachelors. But the problem is the bachelor level, and this is true for a lot of underrepresented groups. And what I would argue is things like teaching computational thinking and other aspects like that need to be going on in K through 12 so that we can increase that initial pipeline. Because if we only have 13% in bachelors, it's going to be really hard to get to 50% inside of the faculty level.
So in my case, I guess interestingly, I think the most success that I'm having in inspiring people is just in my classroom, and I think I'm doing a better job inspiring people to be database people than, actually women specifically. And what I do is simply, I'm passionate about what I do. When I teach, I try to, because databases by default, students think they're not interesting, so maybe that's why I put more effort. And I tell people, look, I always have slides every few lectures that say, look, these are the scientists, this is the problem that they have, and this is the curve that shows how much data they're producing. This is the flat curve that shows how much money they're spending to produce the data, and this is the crazy curve that shows how much money they're spending to process the data. So we need to do something. So I try to, and I actually had quite some success in inspiring just our students that computer science is interesting, data management is interesting, what they're doing is really important. There are a lot of startups that are being acquired. There are so many opportunities. So I guess kind of that's how I'm trying to inspire, and by doing this, I hope that I'm also inspiring the women and everyone in my class.
We at the University of Utah, we have sort of the traditional first-year intense programming kind of curricula for incoming computer science majors, and it's I'm sure everyone probably has an opinion on whether or not that's the right way to do it. But one thing that's unique that I really like that our instructors do is they have this mandatory thing where all the students have to go and interview a real computer scientist. So basically, the faculty volunteer to have a 20-minute conversation with some number of these freshmen. And so for me, this has been one of the coolest things that I've done in this first year, is sort of talking to these 18-year-olds about what I love about computer science and why I think it's like the most amazing field for people to go into. And the thing, again, partly because of my own sort of interest in multidisciplinary work, is to really sort of stress this idea that no matter what your passion is, whether it's in snowboarding or in medicine or in art, there's an opportunity as a computer scientist to make an impact in that field in a way that it sometimes can be much harder to come from sort of the other side. So sort of that, coupled with these absolutely incredible statistics about the sort of plethora of jobs, is sort of the thing that I've been stressing.
So at UNC, and then the thing I did was that I agree that we need to do something more than just within the university or within the college level education, because by that time probably too late. And as a society, we may need to do something that change the perception of everybody of this field, right? And we want to somehow give everybody the image that the people working in our field are cool people, right? are the smart and capable and cool people, not whatever the current image is. And and for myself, and whenever I had the chance to teach undergraduate class, and right now I teach undergraduate database class, and then often try to encourage female students who are in the class and to actually to move on to do a graduate study. And then the way I did is that I always use the NSF REU funding I have to offer, a couple of them, the top ones, and then to give them the opportunity to do research, and hope they will like it, and also build up their confidence. And I also have the opportunity through collaborations to actually get in touch with female students from other fields like biology, and they are in that field. Actually, the percentage is much higher. It's about 50%, and some of them actually are quite capable, and then I try to encourage them to transfer to computer science, and I had a couple of successful cases. But you can see that for those, it's hard to increase the statistics a lot by doing that, right? But it's really a lot of work need to be done from K to 12. Yeah.
Well, and K through 12 is a really important space. I see a number of you in the room who I know are working hard on K-12 computer science education, helping to rebuild it, if it were, in the public school system. And it's very, very important that every child, I think, who leaves high school has had access to a rigorous, relevant, and inclusive computer science course. And we use the word computer science really purposefully at K-12 because our only toehold right now as a community to change something is the computer science AP course. Okay, so as much as we'd like to change it to computational thinking or something a little more jazzy, fun, right now we have the computer science AP course. College Board and the National Science Foundation are working really hard along with Microsoft, Google, and others to think about a new gold standard course at the high school level, and hence a test, et cetera. And so at NC WIT, we all believe that we're not going to attract more girls to computing if, in fact, we don't have that kind of a course. It's just not going to happen. So anybody interested, I could talk for an hour on this, I won't, but there's a lot going on in this space, and it's going to take all of us, and it's so nice to hear you all mention it because we can count on you as advocates, to really get it out there when the time comes.
So with that, I want to open it up to the floor for questions. And so our first question is right here in the corner. Well, let's start there, and then we'll go to you.
Oh, wait, my corner?
Actually, I just wanted to ask you, Lucy, is it on? Yes. Okay. Having kick-started with the NSF, the CSAP principles redesign, I actually wanted to know where we are in that.
Sure.
Is it coming out soon? Are you happy with what is going to come out? Who are the teachers who are going to teach this and so on?
And can you also say your name and what institution?
From Carnegie Mellon.
Sure. I'll tell you what I know. It's changing quickly, although I have to tell you that the timeline is also a little unsatisfying, so we're trying to do some things in parallel. A group of experts has created, as you know, if you go to the CS Principles site, there are, a set of curricular ideas there that there are now, I don't know, 5 or 6 pilots, I believe, of different universities trying out the curriculum. And the reason why you start at the university level, I'm sure you all know that the universities have to teach it and be willing to offer intro credit for the concepts, and then they can back it into the CSAP course and test high school. So I think it's in an early attestation phase right now where universities are saying, yes, we would accept this as intro credit given that the pilots prove out. Okay, so that's where that part is. The College Board has not announced a new course yet. They think they will in 2016. Okay, which makes me feel really old, even older than I am now. So in parallel, we're working on trying to bring teachers up to speed, the Computer Science Teachers Association and others working hard to think about how we can get this done in parallel so that when College Board announces, we'll be ready to go. And there's a parallel effort called 10,000 Teachers, CS 10K Teachers, where we're trying to think about how can we get 10,000 teachers into the classrooms teaching this. But I think everybody here knows there's a long way between here and there in terms of public policy at the local level and how we actually get the course into the schools. So a lot going on. Stay tuned. I think the good news is that the community is really kind of gelling around all of this. And thank you for your leadership in getting it started, because I think that but I still remember, and I'll be quiet about this, but again, I could talk all day. I think it was Lenore Bloom from CMU stood at a microphone at a conference much like this, and she said, we have to have a new AP course. She said something about the CMU faculty all took the existing course and failed it. So just to make a point, right, that it was not exactly what it took to prove success in post-secondary computing.
I'm from Majid Muhammad. I'm from Hampton University, chair of the computer science department there. And we, as a part of our recruitment, we go from, say, Virginia Beach to Williamsburg, and we try to hit every high school, within one academic year. What we're finding out when we get an audience, is that they don't know. Out of all of those high schools, there may be 5 that when you talk to them, they know what really computer science is. Mm-hmm. Most of them think that keyboarding is computer science. So that's number one. And when we go to the career fairs that they have, and we try to talk to them, and we always bring big buckets of candy so they will come to our table, and we talk to them, Jolly Ranchers work, and they come. They'll tell us, would you like to do computer science? And they say no, right away, no. And that's mostly women, but young ladies, but also the males. And we say, why? I hate keyboarding. And so then it takes us however long to explain that that's not what it is. And then they'll tell you they don't like Microsoft Office. I don't want to do that. That's not computer science. And so and we've tried to get into the school systems. And I don't know, Lucy, if you're hitting some of this, but in our area, we volunteer, for instance, to go into the school systems to help them with whatever. We try to propose things to get into the systems. And if it doesn't involve SOLs, we can't get in. I mean, literally, they'll say, well, we want to go in and talk to them about careers and different things like that. That's not necessarily their career fair. They'll say, well, okay, how does this impact SOLs? And if it doesn't, they don't want to hear about it. I don't know if that's just our area, or is that other areas as well?
Actually, you framed one of the biggest challenges quite well. I don't have an answer for it yet. I think that a lot of it is tied up in having standards. We don't have standards for computer science, et cetera. So you framed it very well. That's the road ahead for us, but we have to crack it.
So one last question, and then we have to transition to our call to actions because we only have 8 minutes left. So last question, Mary.
Mary Aiken, I'm from the Royal College of Surgeons. I'm a cyber psychologist. And we've been talking about getting women into computer science, but I think there's another thing we could consider. It's getting computer science into other disciplines. And in that way, we could look at increasing how many women we recruit by, and cyber psychology would be a good example of that. It's in a way, when you mentioned intradisciplinary being very difficult, it is, because you run the risk of not being particularly good at either. But if you concentrate on your speciality in the centre, I think that's a good opportunity for women. And, you know, but the difficulty there is going to be trailblazing in that area. And, you know, they say about the person who invented fire that they were probably burned at the stake, and she was probably a woman.
Okay. So I'd like to kick off with Magdalena and your call to actions to the folks in this audience.
Oh, I see. So the question was, what should universities be doing to recruit, retain more women faculty? And I think actually a lot of the stuff that I have on the slide, the universities are already doing. So we should just, you know, continue and do more of it. And some of it includes things like, of course, you know, if you want to have more faculty, just make sure you actually do interview a lot of women and that you do hire a lot of women. What we sometimes see happening is that each group will kind of nominate their top player, and it's not always the case that the top player will necessarily be a woman. So we just want to make sure that if you want to have a lot of women faculty, we want to make sure we interview and hire a lot of women. The other aspect is that I think there's still, I mean, having had kids during tenure track, it's a huge impact, and the impact is much greater than anything that I anticipated. So this is kind of no surprise to me that people who are before this stage in their life, who are also a big chunk of the faculty, just do not realize that impact, and that it's very hard to make the impact perfectly balanced between, you know, the different members of the family. So this is important, and I think we need to recognize it to then, you know, figure out what we can do about it. And finally, I think we talked about this, that kind of the really attacking the high school, the K through 12 education, and how do we just get people, all of them, excited about computer science. We should have even more people applying to our departments. We should have even more departments. I think that's important to just grow the pipeline.
Mariah.
Yeah, so I guess Again, I've only been in this job for a year, so these are just a few observations of my own experience. But this idea, I think that we were just talking about, like the sort of multidisciplinary curricula and getting computer science to non-majors partly. Like I know for myself, I really want to create an undergrad visualization course. And ideally, I'd love it to be open to students in any discipline. But then people tell me, oh, well, there's this reality of like, are you going to cross-list it in departments? Who's going to get the money for that tuition? That totally, like, you know, as someone who just wants to make this course to maybe pull in more people, I'm kind of like, well, okay, I guess I'll just teach to the CS folks. So it's just, it's I don't know how, you know, senior people, how you sort of get around these things. And then also we found, I took some of our undergrads to Grace Hopper this year, and they were just stunned, you know, and it was so interesting to see them come back, and we had them write summaries. One of them even went so far as to say, I was really thinking of quitting the program. This completely changed it. Just for them to be around so many other women had an obvious impact on them. And then for me, just as sort of a newly hired faculty member, one of the things that actually really was part of my decision-making process of where to go was how much support my spouse and I got in helping him find a job as well. There were certainly some places where there was no support at all. And again, not to generalize, but I think that probably most women, potential faculty members, are going to probably have a spouse who also needs help finding a job in that new location. And for us, that was part of our decision. The mentorship that I've gotten in my department has been amazing, again, for helping that support and for helping in me becoming more confident. And then finally, just as I'm sort of at the phase where we're sort of trying to think about, you know, can we sort of have family and career, this idea of sort of childcare, and I know that you have some pretty amazing ideas on how to make that work, but just the idea of, like, you know, if we had a kid, where would that kid be for me, and how could that sort of work on campus in my job?
Wei?
So I would say that, you know, it's one thing is that to encourage female students to study is like a fellowship always helps, and then that's actually would for other universities, if they have a special fellowship for female student, and then that certainly would encourage a lot of female to move on to graduate school. And I know that, you know, again, that's costs money, and then that's may not be able to to happen at every university without additional help from externally. So, and for that, I just want to encourage whoever, either NSF or Microsoft or, the funding agency or people who are able to do this, think creatively, see what we can do from there. So the second one is that that's echo about this, two-body problem, but I think there sometimes is even actually more than just a two-body problem. There's other things about the environment, the hiring package, and how do you, especially, when you, already settle in one place and then for one reason or the other, you need to move to another university, and then how that transition will be made easier, right? Because sometimes we decide, well, no, I don't want to move because I can't imagine to do all of this myself, right, without hurting my career or my family. So that's one big issue. And then the third item is that maybe we can get more selective and means less community service, because I personally feel like I've been before I left UNC, I was on 5 very heavy loaded committee, like hiring committee, graduate admission, like curriculum, and all those things. You can see that's a lot of work. And the reason I was put on is that every committee needs some female participation, but that's great. But that doesn't mean that that's particularly helpful to my own career development if I spend so much effort to do that. And also, if either university or funding agents give additional seed funding for female researchers, for them to start collaboration or start new research, and to make that easier, maybe restart after they have baby or things like that. So, and that would actually help a lot.
Emma?
And no slide. At my latest period. It was really about increasing the base of the pyramid. I really think strongly that we need to have much more computational thinking in K through 12, and that'll allow us to address not just women, but all underrepresented groups, and really increase their participation in later levels, whether it's computer science faculty or research or industry. I think that'll make a very big difference.
Lucy.
Well, and I wanted to just reinforce one other best practice, and listening to stories. It's so important to ask both men and women faculty what you can do, to improve things in the department. A lot of it is just good culture and good collegiality, if you will. So listening to stories like this, I picked up some pointers. So thank you for that. And I just wanted to encourage anybody who wanted to kind of collaborate with other universities. We have the NCWIT Academic Alliance, over 200 universities who work on best practices and research and other collaborations. Christine Alvarado is here, one of our co-chairs, right over here. And we have some information up here if you're interested in participating as well. But, become a change leader. We look at ourselves as a change leader network of universities, all working, learning. We don't know it all. There's a lot to know. There's a lot to learn. And we're just continuing to till new ground and keep working on this until we're across the finish line with it. And the Academic Alliance, very generously funded by Microsoft Research with a seed fund in the area of practices and trying new things and outreach. And so thank you to Microsoft for that as well. So join up if you're interested.
Wonderful. Thank you, Lucy. So to close, I just want to give you this information, and tomorrow at 2 o'clock, when it's how to engage with Microsoft Research, if you want to come by my table, I will do gender outreach, where I will talk more about our Women's Graduate Scholarship to really help women fulfill their graduate opportunities and their PhD. And then our internships and our fellowships and all of our outreach activities. We have a new website. If you go to research.microsoft.com/diversity on all of the work that we're doing to really try and make a difference. And lastly, in partnership with NCWIT, we are kicking off and having the Sit With Me campaign here. And so one of my challenges to all of you is sit in the red chair to encourage more women to become computer scientists. We will doing video shoots, so you can give your 1-minute pitch on why it's so important to sit in the red chair and make a difference. Or if you don't feel like being on video, you can write a quote and get your picture taken. And what we're really wanting to do is young women need to see and hear all of these stories to know that this is a great field for them. They've got people to look up to, and they're going to make a difference. So with that, I want to thank all of you. And before we end, Barbara has a quick comment.
Yeah, I'm our GM with the Anita Borg Institute, and Mariah mentioned the Grace Hopper Celebration in Computing. This is an annual convening. It's the largest gathering of technical women in the world. We're going to be in Baltimore from October 3rd to 6th. If any of you are interested, you can go to gracehopper.org or just come see me and I'll give you more information. It's a great place to bring students to see a ton of role models and get access to a very rich program. It's kind of a life-changing experience. Thank you.
Thank you, everybody. We appreciate you making the time.